A meteorologist.
He's a meteorologist,
Yeah.
but he does a lot of the Skywarn trainings for the Weather Service. So I'm going to turn this over to Davion, and anybody that needs one of these that don't have one yet, raise your hand and I'll pass these out for you, okay? You're going to need one back there to the back. And there's also some stickers for your window if you want a Skywarn sticker for your window for your vehicle. And everybody here should get one of those. That's a good thing.
Well, I want to thank everyone for being patient with us. Took a little longer than what we thought, but that's fine. We got it all set up. We're good to go. So I try not to keep you guys too long. This is our Skywarn course. We used to do an advanced and a basic and an advanced, but we combined them years ago, so we just have one combo talk now. So try to combine it all together. And I'll go fast, so I won't hold you guys. But if you got any questions, don't hesitate. Just stop, talk to me. We'll keep going. There's a couple built-in brakes, but if we wanted to go fast, we don't want to do that. We'll just keep going. So, all right, we talked about this. If you got any questions, just ask. Want to become official spotters? All of you guys are ham, so this doesn't even apply to y'all. So, all of you guys are official spotters. If you want to do some extra training with this session, you go online. If you Google Comet Skywarn Training, I think you have to set up an account with UCAR to do it, but you don't want to take that class. That's boring. This is the fun stuff. All right. How can you help us? Well, you guys already help us, so because you're active spotters. So this class is really built around what you guys do. To be honest about it, so this is when we go through this, you guys are probably it's going to be like teaching you how to ride a bike. You already know how to do it, so it's like it's really more for the general public, but we want to get you guys refreshed. So being an active spotters, and you guys know why we need active spotters. We'll talk about that. So what's the value of a storm spotter? Well, this won't really apply to us so much because we have good radar coverage in our area, or for the areas that you guys are responsible for. But areas outside of this blue line, essentially, it's when it gets a little shaky because the radar here at the office, and that's it. If you guys know how any local government funding goes, or federal or state funding, good luck getting any money for anything. So we got one radar, and for the foreseeable future, that's all we're going to have. But there are times when our radar goes out. Maintenance, lightning strike, whatever the case. So there's times that we don't have our radar at our disposal, and we have to use Fort Polk, which is somewhere down here. So we could then become the green or the blue line. So what do we do when we don't have radar coverage? How do we fill in the gap? Well, like I said, we're not getting extra radars because we just, funding-wise, that's not going to happen. So we fill it in with spotters. We have spotters to tell us what we're seeing and what we need to report. And that's what the ham community does for us. I mean, I think we get 75% of our reports from you guys. So this is just our office, and that's the radar at the back that I was referring to. And it's what it looks like somewhat inside. This is not actually our office, but it looks similar to that. So a lot of times this is what we're looking at. We're just looking at computer screens. So we don't see anything. But this is what you guys see. On the computer, especially the further out you go from the radar, because the curvature of the earth, the further you go out from the radar, the beam tilts up. So if you're like out in north of Texarkana or way out towards Tyler, we see this, but the public sees this. You see what we call ground truth. So why does that make a difference? Because a lot of times we issue a warning, this is how it reads. National Weather Service detects a severe thunderstorm capable of producing a tornado 8 miles south of Shreveport, moving to the east at 30 miles per hour. What happens when you get this warning? You do exactly what I do. You go outside and look. What's going on?
Wife wants to get in the car and go look at it.
Yeah, we want to see what's going on. Now, is that the right thing to do? Well, if you get a warning that says the same thing, but now it says storm spotters or ham radios are reporting a tornado on the ground near Stonewall, that changes how people react. Now you're going to take it more serious and go take cover. Why is that important? Many times, we only have a few minutes. A lot of times you get warnings, and that 1, 2, 3, 4 minutes is a matter of life and death. So instead of you going outside to look, you get into your shelter or your safe place. All right, so what do we want you guys to report? Or how do we want you to report? You guys know this already. Who, where, what, when, and how. I don't even need to show you this, because unfortunately we have people that send us reports and they never say where the report is from. They just go, hey, I got hail. They're like, where do you live at? Oh, I live off Interstate 20. Like, 20 is a long highway, you be more specific about it. And so they won't tell us the size of the hail. I just got big hail. It's like, okay. So we want to get specific with the reports. So again, this really don't apply to you guys. Most of the time you guys are in our chat room. You know to be descriptive about it. Of course, you know what we want you to report: tornadoes, hail, damaging winds. And we know we don't want you going outside measuring the wind, which, about, hey, it feels like 50. We don't want you doing that. So
Look at your trees outside.
Yeah.
That'll tell you the story.
right. So you really want to know if you're doing damage or not. If it's doing damage, or you can really tell, like he said, trees are almost bent halfway over. You know, like, okay, this isn't wind I've seen before. So flooding and anything else. We'll talk about anything else a little bit. So the main things, we want you to stay safe. We really don't want you being storm chasers. We don't want you going out chasing storms. We really want you to do it from the safety of a building. We don't want to be responsible if something happens or go wrong. All right, how do you relay these reports? Well, on that sheet I gave you guys, there is a 1-800 number on there. So you can call that. But, we also got amateur radio. So K5SHV, you guys may be able to explain that to me. That's
all right, Peter.
That'll either be me or John Beck or Ronnie.
Yeah, and Brian.
Well, yeah, Brian, if
That's right. Okay, yeah. So, law enforcement, local emergency managers, well, again, we get 75% of our reports from the ham radio. But there is a 1-800 number on there. It has an answer machine on it for those younger than 30. Answer machine is like voicemail. But if you talk into it, we'll actually hear it. So just say your report, we'll get it. Sometimes we'll go over there and pick up the phone. So you got the 1-800 number, which is coincidentally right next to the ham station. We're also on social media, just on Facebook and Twitter. So if you want to go on there, you guys got Facebook pages. Everybody does now, I think. You can also email us. But if you got pictures, that's even better. If you can see in pictures, we'll know what's going on. All right. How do you know weather is coming? We put a hazardous weather outlook on our weather page every day. So if you read that, it'll tell you if we're expecting weather or not. It may say no hazardous weather expected. So, of course, if you get a watch, any kind of watch, flash flood watch, severe thunderstorm, tornado, winter storm watch, anything you get a watch, hazardous weather is possible. Of course, if you get a warning, it's imminent. So you guys know this. You don't need me to tell you that. I guess one thing I can clarify is watches, we collaborate. Most watches, the severe thunderstorm watches, the winter storm watches, we do on our own. Well, we may collaborate with WPC. But we issue all the warnings at the office. So it's the National Weather Service in Shreveport that's issuing it, not the television station. So, all right. Get this question all the time. How does severe weather form? Well, in order to get severe weather, you gotta get a thunderstorm. So it's just like a recipe. It's almost like baking a cake. You gotta have moisture, trigger, and instability. Now we get plenty of moisture, and not from Cross Lake, 12 mile bayou. It's from that source just south of Louisiana, Texas Gulf Coast, Gulf of Mexico. That's where we get all of our moisture from. And we need a trigger. So what's a trigger? Like cold front. You might hear upper level disturbance, upper level low, low pressure, warm front. Those are our disturbances. And you need instability. So what makes the atmosphere unstable?
Because you got two pressure systems sitting there starting to fight with each other and building up an instability in the atmosphere.
In a sense, one way, but the simple way is this yellow orange thing that comes out every day.
The sun.
The sun. That's how we get unstable. So, what do I mean by that? So, if you have a combination of moisture and you got the sun out, you can make for a very unstable atmosphere. Like right now, it's what we call conditionally unstable outside. But you know why it's not raining? We don't have any triggers. If you go in the summer, it's 95 every day and humid, moist. It's actually very unstable. But what is it that we don't get in the summertime? Triggers. And we'll talk about that in a minute. So, when you got all three of these, moisture, trigger, and instability, you can get thunderstorms to form. Now, once you get mature thunderstorms, they develop updrafts and downdrafts. So, meaning they'll suck up air, breathe out air. Updraft, suck it in air, downdraft, breathing out air. Suck it in, breathing out. We'll talk about why that's important. Now, if you add something extra to that called wind shear, there's two types. There's speed shear and directional shear. Speed shear is when the wind gets higher with height. So it may be 10 miles per hour at the ground, and you go up 1,000 feet, it might be 70 miles per hour. So the wind is increasing with height. Directional shear means that the wind is changing directions with height. So it's changing directions. So what happens if the wind is changing directions with height? Meaning it's this way at the surface, and that way when you go aloft. What happens? What is it making the air do?
Rotate.
There you go. What rotates? There we go. So, almost that simple. Now, I'm going to talk about CAPE real fast. This is how we measure instability. So if you have CAPE over 1,000 joules per kilogram, now there's several different types of CAPE. You got D CAPE, ML CAPE, surface-based CAPE, MU CAPE. That really doesn't matter. If you got CAPE, any kind of CAPE parameters over 1,000 joules per kilogram, you have an unstable atmosphere. Now, if you start getting 2 and 3, you really got a very unstable atmosphere. So that's how we measure instability by the term CAPE, convective available potential energy. That's how we measure instability. So you may hear people talking about, I know it's a severe weather day because we got a lot of CAPE out there, or they're saying they have a lot of instability. So we'll go ahead and breathe. All right, we talked about wind shear, so we don't need to rehash that. All right, so let's put all that together and see how this works. Now this is what we call a typical summertime thunderstorm. Popcorn thunderstorm. It has very low wind shear with it. You know, you get, in the summer it's not windy at all. The air is very stagnant. This is what we get. You notice in the summer a thunderstorm will develop at 3, and then an hour or so later that thunderstorm dies off. That's because it has no wind shear to it. So what happens is, you see this tall column? That means it has a tall updraft. So it's sucking in a lot of air. But because there's no wind shear, the updraft and the downdraft are right together. So it's basically choking itself out. It's breathing in and it's trying to breathe out, but it's breathing in at the same place where it's breathing out. So it's choking itself out. That's why it's dying. Now, this is just like me. A marathon runner can breathe in and out and run all day. I'm like the popcorn thunderstorm. It's just 15 minutes, I'm out. All right. Now, what happens when you have a thunderstorm with a lot of wind shear? What happens is, remember we talked about the winds get greater with height, right? if you have direction, if you have speed shear. So meaning the winds are at the surface, this miles per hour, when you go higher, they're higher. What it does is it causes a thunderstorm to tilt. See the top of this storm? Instead of it being a straight column like the other one, it's more tilted. Why is that important? Because now the updraft and the downdraft are displaced from each other. So meaning this storm can breathe in and breathe out. Breathe in, breathe out. So it can keep going. It's why you'll get a thunderstorm develop in Dallas and you go, man, it made it all the way to Shreveport. Because it has a lot of shear in it. And it's able to breathe in and breathe out and keep going. Keep going. So that's the importance of having mature thunderstorms with wind shear. It keeps the thunderstorms going. Now, of course, remember, we got a tilted thunderstorm that's breathing in and breathing out. If we also add directional shear to this thunderstorm, where the winds are changing direction with height, what does this storm do?
Starts rotating.
Starts to rotate. And that's how we get what we don't want to see. All right. I hope I made that simple. We talked about triggers, cold front, warm fronts, etc. So it's just an example of some triggers. Can anybody find the front on looking at this radar? I bet you all can.
Oh yeah.
Where is it at?
This line.
Of the state.
This line or this line?
That line.
This one right here?
Yeah.
Well, I knew it.
Yeah.
You guys are all Mets. We can go home now. All right. Exactly where it's at. This is what we see most of the time in our area. Cold front comes through, triggers off a bunch of thunderstorms because we have a warm and unstable atmosphere ahead of it. That's what we see. 85% of the time is what happens. All right. Severe thunderstorm. What's the definition? It has to have hail of at least a quarter size or greater. You can have that. Or winds 58 miles per hour or greater. This is a lake, y'all. This is not an ocean. This is Lake Cherokee. That is not an ocean. I think this storm had 80 mile per hour wind on it. I got a report from there. So it can have either or both. Or both. Sometimes it has both. And sometimes it has all three. A tornado, by definition, is a severe thunderstorm. So, tornado, funnel cloud. So all three. Notice this date. January 21st, 2017. That's important. Why? Because tornadoes can happen anytime. Any time of the year. That's why we do these storm spider class in the fall and in the winter to get you prepared for the spring, the fall, winter, severe weather season. So notice this. Notice the peak is here and here. Why is there no tornadoes hardly in the summer? No triggers. Exactly. There's no changing in the atmosphere. I can give you the forecast from June to September. 95, 75. And that's it. It's really pretty simple. Pretty much. No triggers. No triggers. Only time we really get triggers in the summer is with a landfalling hurricane or a tropical system. And what's a tropical system? It's a low pressure, a trigger. Most of the tornadoes we get in the summer, I would probably say 85–90% of them are associated with tropical storms. So that's what we usually get. We don't have any triggers. The atmosphere is the same usually the whole summer. Now, why is it more in the spring versus the fall and winter when we get triggers during both times? Anybody know?
We're still getting those cold fronts coming out west over the Rockies, coming in and meeting our Gulf moisture right there. It's trying to warm up, but the earth is sitting there saying, we're going to still try to cool it down, trying to hold
that is, you're about 85% right there. You're on the right, no, you're on the right track. So, what you're saying is just about true. What happens is, in the spring, the warm air is starting to win out. So the warmer remember the sun makes the atmosphere unstable. gotta have the sun. It's just like boiling water. You put water in the pot, the triggers when you cut the stove on, and the hotter the stove gets, the more the water's gonna boil. Same thing with the atmosphere. The hotter it is, the more unstable it is. So in the spring, the hot air is winning out. So when you get severe weather in the spring, it's 85, 90 degrees outside. In the fall, the cold air is winning out. Because the cold air is trying to displace the warm air. So now when you get severe weather in the fall, it's like 65 degrees. So the atmosphere is not as unstable as it would be in the spring. So even though the setups are similar, you usually have a lot more instability. Now in the summer, the atmosphere is extremely unstable. We just never have any triggers. So the atmosphere is so unstable that we just get popcorn thunderstorms. That's how unstable the atmosphere is. That just the heat of the day will trigger a thunderstorm. But there's no wind shear, so the thunderstorms just kill themselves off. So, all right, anywhere too. They can have it any time of the year and anywhere. It's 1950 to 2021. I think the Earth is at least a couple years older than 1950. So, gotta remember, I don't want to go into this too much, but if you don't see a track here, well, the reason why we get more tornadoes reported now is probably most of that is due to technology. We got Doppler radar now. We didn't have that years ago. Everybody has a cell phone now. In 1950, if a tornado hit in the middle of the woods, nobody knew. You didn't care to report it. You may just tell your neighbor down at the corner, man, I saw a storm knock Tom's chair off his porch. He just went back, that was it. Now, a tornado knocks Tom's chair off his porch, you got it on camera, you called every TV station, and now we got to go out and survey it and report it. So, yeah. Right. So is there necessarily more tornadoes now than there ever been?
More ways for it to be.
Personally, I don't think so. But, but we don't want to go into that. I think it's just technology. I think it would take about 50 to 100 years with the current technology to know if we're actually really seeing an increase. I mean, because again, if you're going to go pre-Doppler radar, of course there's going to be less tornadoes. There's no radar to, see it. So, all right. So if you hadn't been hit by a tornado, it's really just been lucky. So you can't go where I live on the other side of this bluff and a tornado can't hit me. Yeah, it used to be a theory it couldn't hit big cities, but we've seen that. Yeah. So how do we measure a tornado strength? This is really important. Well, we go out and do all the surveys after if a tornado is suspected, the weather service. So EF0 to EF5. We measure it based on the damage. Because we don't really have people next to the tornado throwing up anemometers going, oh, okay, that's 100 miles per hour. Like, we don't know. So all we can do is buy the damage. I'm going to reiterate that. All right. Look at this. Which tornado is stronger? This one on the left or this one on the right?
One on the right.
That one? Yeah. Obviously, right? Yeah. But of course, you guys going, it's obviously a trick question. So,
that's what else.
So you're going to say it's the one on the left, right? Well, there we go. Well, they're actually the same strength. So it was a trick question.
Depends on where you was taking the photo.
Yeah, same strength. El Reno, Oklahoma, F2, rope tornado, wedge, Seymour, Texas. Remember what I said. We measure by the damage. Look at this. Open grass pasture, couple cows. This is just a bunch of dirt. Remember, tornado is just wind. Hurricane is just wind. What you see is the debris that it's picking up. So this is picking up a bunch of dirt in an open field out in the plains. So it's very well possible this is stronger, but it didn't hit anything. So I can only tell you the strength based on the damage that it did. So if it never hit anything, of course, this could eventually look like this, but it hadn't really encountered any debris. This is just a grass field. I say that to say, if you see either one of these, take them both seriously the same. Don't go, hey, look at that, I can drive right up next to it. But you never know how that storm is behaving, because it's probably hadn't encountered any debris to make it look like that. So treat both of them like they're EF5. Stay away from them. That's my motto.
I got a question.
Go ahead.
Can you describe a rain wrap tornado?
Okay, so a rain wrap tornado essentially means, so because we live so close to the Gulf versus like in the plains, that our moisture content is really high in our area. I used to have a slide on rain wrap tornadoes on here. Our moisture content is so high that when we get thunderstorms, they produce, like in the plains when you can get dry thunderstorms in the plains. I mean, you can get a thunderstorm develop and they have very little rain with it. It just got a lot of thunder and lightning. Whereas here when we get thunderstorms, our moisture content is so high, we almost get flooding rains sometimes. And so what happens is, if you get a tornado develop on a high precipitation thunderstorm, when it starts to rotate, it's just wrapping the rain around it. And so it's blinding you from seeing the tornado, because think about it, when it rains real heavy and you're driving, you can't see. Even just the rain, the visibility goes down because there's so much precip falling. So if that's wrapping around a tornado, you can't see the tornado. So that's what a rain wrap tornado means. It's just a tornado that formed in a high precipitation thunderstorm.
I appreciate it.
Yeah, and that's common around here. That's probably what you're gonna see most of the time. Probably half the time. It's a built-in brake, but it's really just here to show you guys. If you go to weather.gov/SHV/spotter, this is how you get your certificates. Now it says label yourself trained spotter, but you guys are amateur radio, so label yourself amateur radio. And do some feedback. 1's not good, 5 is great. If you're gonna put 1, just skip this whole thing. Don't worry about it. Just skip it. So, we'll figure another way to get you a certificate. No, seriously, let us know. Give us feedback. Tell us what we need to improve on. All right, we're gonna keep going. All right. If you are outside driving and you see a thunderstorm far away and it has an anvil top on it, that tells you that is a very strong thunderstorm. That means it has an updraft so strong it's reached the equilibrium level of the atmosphere. And it's formed an anvil. The clouds flatten out because it can't go up anymore. Now, if you see it overshooting top, meaning that a little cloud punched through the anvil, that tells you, again, it has a very, very strong updraft. So if it's sucked in a lot of air, that means it's got to breathe out a lot of air. So that means it's going to have a strong downdraft. So that's just telling you that's a very, very strong thunderstorm. Of course, if you keep going, you get closer in, it may look like cauliflower. Probably see thunder and lightning within that. That's another tell sign it's a strong thunderstorm. So if you're driving down the road, see an anvil far away, and you get closer and it has this cauliflower look, hey man, I'm about to run up on a pretty good thunderstorm. So just be aware of that. Wall clouds. They rotate, persistent, rising motion. Main thing is the low-hanging clouds, usually a precursor to a tornado. The tornadoes drop out of the wall clouds. But they are rotating. They are rotating. They come in many shapes and sizes. They look in many different ways. You don't want to be here if that's happening. But I get it. I was raised in a mobile home, so I know how it can be. So we'll talk about safety for that in a minute. But the question is, if it's rotating, it's a wall cloud. If it's rotating, it's a wall cloud. If it's rotating. This is me down North Market one Sunday, and I saw this, and I went, whoa, what in the world? But I didn't look long enough, because it was just an electric smoke factory. It wasn't rotating.
That's funny.
Yeah, it wasn't rotating at all. So,
It's Arsenal Hill.
yeah, I should have been paying attention a little bit more. This is scud. I keep forgetting what scud means. My coworker has told me this a million times. I think when we were in Atlanta, my coworker told me what it was, but I forgot already. But essentially, it's a low-hanging cloud that can resemble what looks like a tornado. And if I saw this or that, I'd get nervous too, like I did with the smoke electric plant. But if you pay close attention, what is it not doing?
It's not rotating.
Not rotating at all. There you go. So it's just scud. Scud, scud, scud. Not rotating. I don't know why this is on here twice. We'll skip that.
So people's not confused.
Yeah. Chef clouds. Now we get this a lot. These usually develop at the front of a storm. It's usually the outflow boundary or gust front. When you see them, sometimes it looks like a dust storm or something that's headed towards you. A little rising motion, almost looks like a spaceship. But usually what happens is when they come, you get a gust of wind, then you get your heavy rain, your hail. You guys ever notice you right before a thunderstorm hits, you go outside and you go, man, it got cooler and the wind picked up, it's probably finna rain. You probably just got hit by a chef cloud or the gust front, or outflow boundary. I hear different names. That came at you. And so a lot of times people see them and they get nervous. Here's one in Louisiana Tech. Yeah. There you go. All right. Tech's done something good, huh? I went to ULM, so we're right. All right, look at this chef cloud form. People see this and they call us and they go, oh man, what is going on? So these chef clouds, like I said again, are outflow boundaries, gust fronts. So they act like little small cold fronts when they come through. Knock the temperature down. But they're at the front of a thunderstorm. So that's when you get your hail, your gusty winds, then it's followed by heavy rain. So you guys have probably heard like people say, man, it got windy, then it started hailing, then I got hit by the tornado. The hail was first, then the tornado. Because the tornado is on the rear of a thunderstorm. And the wind, the downburst winds and the hail are at the front. So that's what you see with chef clouds. That's where you get your straight line, downburst, microburst winds. Kind of like this. See, we getting the hail first, and we getting the wind. That is not a hurricane. That is downburst, straight line wind. Look at that.
And looking at those trees, I guess that around 65.
Oh, easily. That's pretty good. Oh, yeah. That might be better than 65.
Oh, yeah, that's about 75.
Yeah, that's pretty good. That's probably what we got. That's what we got to do in the last. Yeah, so we got this one.
Hell, we got
Here's another example.
last June.
Yeah,
Hey, are those referred to
same.
microburst also?
It's slightly different, but
Hey.
essentially the same.
Okay.
That could have been a microburst.
Wow.
But essentially, it's just they're all straight line wind damage. Now you see that? Now what you think those kids went and told their parents? They got hit by a tornado, didn't they? That's because downburst winds can do damage up to EF2 tornado strength.
Really?
Yes. So many times we go out and do a survey and we say it was straight line winds, and we almost have to run back to the car because they're pretty upset with us. They don't want to hear that. Everybody wants to get hit by a tornado. That's the sexy thing. So.
The difference in a straight line wind degree field and a tornado degree field is the tornado in opposite directions while the direct lines straight run through it.
Right, and I'm glad you said that because that matches up with our slides right now. This is damage in a wooded area, Texarkana. Brian Loper probably reported this. See, all the trees are fanned out in one direction, pretty much. They're all going that way. Straight line winds. This is plain dealing. The damage is really the same, except this is circular. But the scope of the damage, what it did, is almost similar. It's just one is straight line and one is circular. So we just put this on here to show you that the damage can be the same from both. There's no shame in getting hit by downburst winds. All right. You're in a